Hi, yes, I'm using a different camera with a different look because I'm going to do something today that I think's rather interesting. I haven't done it before, and that's to not, I guess, calibrate, but look at the responses of my studio monitor speakers here. I've got the Rokit 6s, which is the one I repaired, or Rokit, however you want to call it. I call them Rokits. And I've got my Rokit 6 monitor speakers. I've changed them over from my Alesis M1 USB 520 actives because I've got the new Rode A1 AI1 interface here, so I actually don't have USB connected monitor speakers anymore. I take the analog out from there directly into the speakers via a balanced quarter-inch jack. I've got my Rode mic here. Oh, sorry, you're probably... the acoustics aren't very good because I'm not talking directly into my mic. Anyway, I thought I'd just actually get the response of the monitor speakers here. Now, if you're setting up studio monitor speakers, you're supposed to have them basically an equilateral triangle. So they're at head height. So I sit here like this, and it should be an equal distance from one speaker to the other as it is to each ear. So it's normally a 60-degree angle like that, and that gives you an equilateral triangle. Basically, that's like determined to be the optimum kind of layout. So I thought that we'd take a look at actually get the response, because I'll use this microphone. I don't have a proper measurement microphone. You would normally do this, you get what's called a measurement microphone, and it's specifically designed for getting room acoustics and other measurements of, or in an anechoic room audio, anechoic chamber, for example, for measuring the response out of speakers and stuff like that. I don't have one of those, but we'll use the mic, and we'll actually set the mic into the position here, like this, where my head is, and then we'll do a sweep on it, and then we'll using some room acoustics, some really cool open, I don't know if it's open source, but it's free room acoustic software. So let's take a look at it. If we go over here, and we can check it out. It's called ROO, or Room Acoustics software, and it's a free Windows download. I highly recommend you check it out. It's really very cool. I haven't played with it much, but I've done a basic sweep, but I thought and it kind of works, and I've got my sound level meter if we need to set it up, for example, but you can do it, you can actually run it without setting up the sound levels and stuff like that. You can just sort of wing it. Anyway, let's run the software, give it a go, and see what we get. I don't normally have these acoustic panels behind me, so I was just recording the amp hour earlier, so I'll get rid of those so I have my normal space. Now, this is obviously not an ideal arrangement here because I have the wall directly behind me, obviously, so the speakers are bouncing out off the wall. There's going to be reverb back, there's going to be reflections back, and then they'll reflect back off the monitors, and we'll be able to see that hopefully in the waterfall plot when we do the response of these speakers. So this is definitely not the best environment, having a hard wall behind you for the studio monitor speakers. And the Rokit 6s do have the front firing bass ports on them, so they're potentially better for smaller rooms. So normally, you'd have a desk against the wall, but I don't have that. I sort of have the wall just directly behind me here. So it's kind of a non-ideal setup, but I thought we'd sweep it with the microphone I've got. It's a Rode M5 microphone. So anyway, let's give it a go, shall we? So this is my first time using this software, so please forgive me if I don't know all the ins and outs of this thing. But if we go into measure here, SPL meter reading has not been calibrated. Calibrated measurements cannot be made until the SPL reading has been calibrated. Results may not reflect actual SPL values. And as I said, you don't have to. You can just cancel, or you can just continue anyway, and you can get your response, no problems whatsoever. But because you're just guessing at the signal level, it'll actually tell you whether or not you have a high enough, like where you have a poor signal level, or whether, it's in the green, good enough, as we'll see. But let's actually calibrate the SPL, because I have an SPL meter here. So let's give it a go. Haven't done this yet. All right, so we choose our signal source, and we want the speaker calibrator. That'll do. And whoa, Whoa. It's outputting something. Sorry, I can't get the other thing on the screen because I can't drag it. Adjusting until it matches a reading on your SPL meter. So there's my SPL meter. You want it, got it to 80 dB range, and you want a weighting on it. So here we go. It's about 71. Finished. Whew, that was noisy. Anyway, it's set up, so now the SPL figures should be reasonably accurate. Maximum SPL with this calibration is 111 dB. I don't think we want to go that loud. So if you need higher, then we'll need to be reduced. Nah, we'll be right. There we go. It's got a funky little dB meter there. So my background is 38-ish. It's not great here because there's other noises from offices next door, and there's, I don't know, you know, there's like stuff happening. So it's not the best environment for doing audio. Anyway, we're just having fun. And you've got stuff in here like you can do like a tone generator, so you can generate pink noise, and there it goes. Sure, you can generate white noise as well. Yeah, white, pink, you know, and shape noise and sweeps and do all sorts of stuff. And you know, it's ridiculously powerful, and like, and it's even got this room simulator. This is really cool. Check this out. Like, you can actually set up like the size of your room, and you can set up where you set up where where the person is, you know, / microphone in the room. Yeah, so that's a subwoofer. Then you can go left and right, and there you go. You can move your speakers around. There you go. Move your speakers like this, and then you can move your head around, and you can see the modal distribution response of that. Now, I've actually got my room actually set up here where I am, but it looks like it can only do like it's only designed for like subwoofers, like for the low frequency stuff and things like that. So I can't see how to actually get any higher than that. So unfortunately, because we're going to do a 20 hertz to 20 kilohertz sweep today. Anyway, don't want to dick around with the room simulation anymore. I just think it's neat. Just want to show you all the other insane stuff it's got. Like there's this equalizer measurement system here, and you can choose your different brand of equalizer here. It's just, it's absolutely insane how much work has gone into this program, and it's just completely free. Like, it's just absolutely brilliant. If you're setting up a recording studio and you're absolutely serious about stuff, that, you know, you're serious about your responses and your setup, this is just amazing. All right, so let's go into measure here and make a measurement. SPL, start measuring. Okay, so what we want to do is 20 hertz, 20,000, 20 kilohertz. Level, mine, I'll just leave it. Do we want 8 sweeps? Get a maximum number of sweeps. It's a bit many. 20. It'll take 43 seconds. Let's do it. Let's do 8 sweeps. Presumably it'll do the 8 sweeps, gives you an average, and then, you know, it's much better than just doing a single sweep. So we can check our levels. Sounds good enough, like we had before. Oh, hang on, I better shut up. I need to actually set up my microphone in the correct position first. Let me do that. Right, so there it is. You just point it in the center like this. You have it exactly where your head would be, like this. And of course, yeah, you should use a proper measurement microphone. But in this case, we've got the Rode M5. It's a cardioid mic. But I maybe sort of like it's because it's cardioid pattern and your ear. If you're sitting here with your ears, that would... you know, your ears are not cardioid, but, you know, they're designed to more get stuff from the front than the rear. Meh, I don't know. It's all I've got. We're just playing around. Let's go. Level is low. There you go. So we need to increase our level. I could just... well, no, I can't turn the speakers up because I've already calibrated the level. Okay, it won't let me go to less than -3. Bugger. Damn, I'll have to recalibrate it. Okay, let's try that again. I've recalibrated. Level okay. Let's leave it at that. Beauty. Oh, actually, let's do it. That was pretty loud. So let's just do what try -6. Level okay. So let's stick with -6, shall we? Start measuring. Now the good thing is that you can set a delay so that you can bugger off out of the field here. So let's do it. All right, David, don't make a sound. David's in here as well. So we'll set it for a 3-second delay. We'll do 8 sweeps, and I'll come back to you. And we're done. Awesome. Here's our response. Let's take a look at it. All right, so what we've got here is the main sweep, and if we actually, you can go in here and change the calibration. So if you've got like a proper measurement microphone to actually do this, they might provide you with the calibration data for that, and you can import the calibration data of your measurement microphone. So, like, you know, it's a really professional solution for this thing, but we just set up the SPL, and, you know, it's not a proper measurement mic. You know, it doesn't have the proper performance. We're just doing this for shits and giggles. But, you know, it does tell us, even without a proper measurement microphone, it's, you know, it still tells you stuff. It allows you to, you know that you've got, you know, reflections at certain frequencies and stuff like that. So this is our main sweep here. So we've got our dB on the y-axis here, and then we've got a log sweep axis here from 20 hertz up to 20 kilohertz. And what you want with reference monitors is you want this response to be as flat as possible. So, you know, it's like, well, okay, we know it's going to drop off here right below, like, these speakers only have a response of like 40, 50 hertz, and that's exactly what we see here, actually. So, you know, just ignore this crap at the bottom. In fact, we could probably change the scale on that, can we? So we can just like look at the low end like that, and you can see that, yeah, these Rokit 6s have like, I think, a nominal response of like 40 hertz or something, like a low end of 40 hertz. And sure enough, that's where it like starts to, you know, drop off at 3 dB down or whatever. But of course, this is not accurate measurement, so take it with a grain of salt. But you can certainly see the roll off below 40 hertz because they, you know, the 6-inch woofers just aren't capable of anything else. Now, 6s, I think it's 2.8, 2.9 kilohertz, and that's the crossover frequency. So you can actually see that in here, but you can see these other responses. Like there's one at like 870 hertz here. There's a big dip and stuff like that. So, you know, 414 hertz, and that's going to be due to your room acoustics. There's another horrible one up here at like 8.5 kilohertz and stuff like that. These are reasonably good speakers, so I don't think it's actually necessarily the speakers as such. You can start to see it, you know, it's a really tight grouping up here at the high end. So the, you know, the tweeters are doing their job. It's the lower frequency stuff that's really going to be, you know, bouncing around and things like that. So you're going to get a lot more variability. So we can look at, that's all the SPL. We can look at the distortion. We're not worried about that. Impulse, filtered IR. We're not particularly concerned with those. What I want is the funky waterfall plot. All right, here is the fascinating thing which potentially shows up the limitations of not using a proper measurement microphone and also moving your microphone between tests. This is the original sweep I got. It was done at -6 dB, okay? And this actually looks like a really nice, tight response. It's pretty darn good here, especially tight up at the top end there, because you want a response that is as tight and as flat as possible. And that's actually, you know, apart from the odd, you know, there's a dip here, and there's, you know, there's a dip here, and there's a dip here. That could be the crossover frequency there, but, you know, the speakers aren't supposed to, you know, cause an issue if they're well designed on that sort of stuff, right? That's fine. But I actually redid this. Check it out. This is exactly the same scale. I redid it. I don't know how to actually overlay 2 on 1. Sorry if I can't do that. And this was the same. I repeated the same test, but I had moved my microphone back here, recorded some stuff, moved it back. So there could be like subtle differences in not only the distance, but the, you know, the orientation, the angle of the mic and everything else. And look at this. It's the same -6 dB signal level. That's really fascinating. The top end here is very similar. Like the top end shows the same response. So hence why, you know, so that shows that, like, and you wouldn't expect the low frequency stuff to have a directional capability, like to cause directional problems with the microphone. So the microphone should give, and it does show, that it gives basically the same response at, you know, on both of those. But the higher end stuff, look at this, it's got this big dip off, like right up here at like 15 kilohertz. What's going on there? This was done at the same signal level. So it's really bizarre. Anyway, I tried it with panels as well. So this is with the panels, and I tried it at a lower signal level, minus 12 dB. And look, we get a couple of dips up here at the low end. We get another dip at around, you know, 7.5K, something like that. Got a few, you know, it's not terrific around the 3 kilohertz range there. And then I did that. That was with panels, and then I did it the same thing without panels, and I didn't touch the mic in this case. I simply removed the panel. I don't think I touched it. And I simply removed the panels. So this is with the panels is actually worse than without the panels there. So, like, well, it depends on how you deem worse. Let's actually go and take a look at the waterfall plot, which will show the decay of the each frequency with time. So if we go over to EQ here, so, there we go. We can get a combination of the waterfall plot and that. We don't want that. We just want the, sorry, I can do overlays. Let's have a look. So let's overlay, what was it? The red one and the green one at the end. So they're the two responses overlaid, and like you can probably see like the differences in the location of the mic. I don't know why on the second sweep it's so damn, like, look at all these big drops around here in the, you know, the mid like 3 to 7 kilohertz range. It's remarkable. It's absolutely remarkable. So was there more ambient noise here or something? I didn't hear anything. But you can see that, you know, look, you can see like the same spike here, for example. Like you can see the same dip here is basically the same with both of those, you know. So that's consistent. You can see that the dip at 870 odd hertz, that is, you know, consistent, but it's like a different signal level and stuff like that. So you can see some of the things are the same, but yeah, for doing supposedly the same measurement and just moving the mic. But the biggest thing is this huge dip right here, and I'm not sure what that's got to be a positional thing with the microphone, either or up like that, or, you know, the combination of all those. So it's makes a difference. That's the response with panels, and that's the response without the panels. So both of them show this big dramatic dip at around about 13 odd kilohertz there. They both show that. But with the panels, we get this extra content at around about this extra dip at 8.3 kilohertz, which we didn't get. That's really weird, isn't it? So you know, I need a proper mic, and without the panels, you can see that there's more broadband dip in here. So it has actually, the panels have actually cleaned up that somewhat, and both of these were done at the same signal level, minus 12 dB output reference, but that's doesn't mean anything unless you actually reference it to a SPL level. But anyway, that's interesting. Panels, no panels. Okay, let's go in and have a look at our waterfall plot here, and it's got the same response on the vertical axis as before. That's our signal level, and it's got the same 20 hertz to 20 kilohertz we had before, but the one at the back, sorry, my cursor's not showing up on the capture here. I don't think it's showing up on the screen capture, at least not on my thing. But the back of the waterfall plot, so to speak, it slowly builds it up over time. The back is the 0 time reference, as opposed to when it was generating. So that's the instant it was generating that signal, and then over time it builds up progressive captures, like full spectrum captures over the whole frequency range of each decay in time after that. So it's basically how the sound decays over time. So it takes time for the signal to come from the speakers, bounce off this hard-ass back wall here, and come back to the microphone. And you'll see that in the response. So what you want is not only the fastest fall-off possible, but also the flattest bottom edge of that waterfall plot. You want that to be like, you know, really like nice and flat, and it's reasonably flat over the range here. And we can go in and have a look at the other ones like that, but you can see that, oh, there we go. Let's regenerate that. You can see the volume in there. Oh, there we go. We haven't generated that one yet. And you can see that it's muddier around. This is with no panels at minus 6 dB. You can see that's muddier around the 2 kilohertz to 4 kilohertz range. And if we compare that to the original one over here, you can see that it's tighter across the frequency range, and there's not as many reflections there. So that could be the positional difference of the microphone. I may have had it at a slightly different distance because I did actually reset up the microphone there. So you can see the difference in the waterfall plot there, but you can see like at the bottom end and stuff like that, around like the 130 hertz and stuff like that. This is like, you can get rid of stuff like that by having like bass traps over in the corner. Like a lot of people will, like, corners of rooms are notoriously bad, and you'll put a bass trap in there to sort of like equalize that sound out and stuff like that. So anyway, it's fascinating. This is the, here we go. This is the minus 12 dB signal level with panels and without panels. And you can see that actually with panels, it seems to be a tighter spread. There's, oh no, I'm not going to say that. I'm not going to say that. But it's more even. I'd say with panels is potentially better. It not only falls off a little bit quicker, especially around that 2 to 4 kilohertz mark, maybe something like that. That sort of window in there. If you have a look at that, and then compare it to this one out here, yeah, it comes out further. So there's more decay there. It takes longer. The sound is like taking longer to get back. It's like it's reflecting back off the wall and coming back, obviously. So the panels do help there, but you know, not by as big a margin as you would think. So, you know, they add their own, I'm not going to say they add their own, no. I'm looking at around, you know, 260 hertz there. That peak is still there. So the panels really didn't get rid of that. And they're not getting rid of this reflection here at 124 hertz. Certainly it doesn't, it's not doing anything there. So that's obviously, you know, the panels weren't effective there. These sorts of foam panels just aren't going to be really effective at those really low frequencies. You need the much deeper, thicker ones that thicken the material. And I've done videos on assembling my own acoustic panels, not only these ones, which were easy, just off-the-shelf tiles, but actually assembling my own using acoustic foam. I'll have to link that one and it's the thickness of the acoustic material you've got inside that determines its effectiveness at the low frequencies. So, you know, at 124 hertz, that's really low. I wouldn't, you know, you really need thick ass stuff to really make a difference down there. But there you go. The waterfall plot, just, you know, it's a nicer way to look at it than just your response here, because it actually shows, you really want to look at this because it shows your decay and your reflections over time. So this is the more important one, but that's, you know, it's not too bad. Even without the panels, it's, I don't know, I'm sure there are audio, you know, audio engineers out there who will no doubt analyze this until the cows come home and tell me that my setup is shit. And I don't disagree. It probably is completely shit. Because I'm like, you know, I'm sitting right against a hard wall like this. But the panels, I don't think, make a huge amount of difference. So that's no panels, and that's with panels. You know, it helps, but, you know, I'm not going to write home to my mum about it. Anyway, there you go. That's just playing around with this really cool software, Room Acoustics software. I'll link it in down below, and it's free, and you can use it. And maybe I'll get like a proper measurement microphone or something. I don't think they're hugely expensive, like Behringer make one, and other companies make these measurement microphones specifically designed for this. They're designed to actually, you mount them vertically. Generally mount them vertically like this, and they have a pattern all the way around, so they get the reflections and everything. Their patterns are designed for, and their responses are designed, and you get a full calibration certificate with it and everything else. Designed for measurement applications. We're just dicking around with a cardioid Rode mic that I happen to have here. So, whatever. Like, maybe I could actually redo this sweep with it vertical. How about that? Let's have a look. Just for kicks. So let's actually try this, and you can actually see that it's got, if I put it vertically like that, it does have the things around the edges there. So maybe, we'll definitely get a different response like that. So I'll whack that there like that and see what we get. Could be interesting. Okay, now I won't touch the mic, and I'll just put some panels in the back. Okay, so let's have a look at our response here. Haven't seen it yet. SBL and phase. And, wow, look at that. So that's with, that's minus 6 dB, so it's the larger signal level. That's without panels. And with panels, there you go. It's a bit cleaner. And that's not touching the mic at all. So that's, but you can see the same dips. Like the same dip is here between the two. But with the panels, you get rid of that dip there, whatever that dip was. This dip here is the same. So, it's tidier. It's tidier with the panels. So let's go to the waterfall plot. Generate that. And generate, so that's without the panels. This is with the panels. I think we'll find that it's going to be tidier. It's going to not stick out as much. So look at this range in here, and I think you'll find that it'll stick out further. I.e. there's more decay with the no panels. There you go. There's more decay at that vocal range, actually. It's kind of like in that vocal range there. So yeah, the panels help. The panels help, definitely. There's no doubt about it. But at the low end, there's virtually no difference between the two. Yeah, like have a look at down here at like 40 to 50 hertz. It is identical. It is absolutely identical between the two. And at like 120 hertz here, like, like the response, the decay is just, it's very similar. So it really changes it around this mid-range here. Both of them actually up at the high end. Yeah, if you go right up here at, at like your 10 to 15 kilohertz, the decay response is, a little bit worse at 10 kilohertz, but basically at the higher frequencies, it's exactly the same. So there you go. That's interesting. I hope you found that fascinating. And if you are like an audio engineer and into this sort of stuff, please leave us details in the comments, because this is not really my my field. I'm just having to play around with here, and not with a real mic. And it'd be interesting to get a proper measurement mic though, and sort of, do some real measurements. But let us know what you think in the comments down below. If you like the video, give it a thumbs up and all that sort of jazz. Catch you next time.